and good day, Algebra. We have made it to the end of our exponent rules, 5th of 5 today. And it has to do with when you've got parentheses. Okay, we've talked about how parentheses can affect what your base is. We've seen before how something like 3n to the fourth is very different than 3n to the fourth when that's in parentheses, right? Because now the 3 is part of the base. When we talked about the 0 power on our homework, we talked about how something like that would be positive 1, whereas something like that would be negative 1. Okay, so parentheses do definitely make a difference. Today, if you'll notice, what we're going to focus on is not only do you have parentheses, but you've got other stuff inside the parentheses as well, like 3n to the fifth to the fourth. Okay, so this rule is called a power to a power, right? You've got an exponent that's part of your base, and then you're raising it to another power. Okay, what's going to clue you in that you're using this rule? What do you see is present in all 3 examples that we have here, and it's present in all of your example problems? Parentheses. Okay, so parentheses are going to kind of clue you in that you're going to be using this rule. To accomplish this, we'll be doing something called distributing, and I think you've had experience with this before. Mathematically, what does it mean to distribute something? Or even non-mathematically, really, the definition kind of lines up well. Kylie. Yeah, so Kylie's mentioning something. If you've got something outside of parentheses, okay, you would get rid of those parentheses. We actually talked about this back in PO7 by distributing in, right? You'd multiply the 3 by the x and multiply the 3 by the 4. It's the same idea here. Crinkle, were you going to add something?
So let's say you have 4 cookies. And
you got me. All right, I'm listening.
Oh,
you lost me. Okay. So you're distributing the cookies to your friends. Okay. Hey, folks, way too much chatter today. Way too much chatter. I think you being in first place on the Fantastic Four, despite having the least number of guesses gone to your head. Okay. You will fall off the wagon eventually from losing guesses. Don't lose one today. Okay. So in this case, for this rule, when we talk about distributing, we're going to be giving the power to each base inside of our parentheses. Okay? We'll be giving the power to each base inside of our parentheses. And just like we've done before, we're going to kind of go to expanded form to see exactly how this works, and then develop a rule from that we're going to write below. You can put it on a help sheet, and it'll be good. So expanded form here for 4n squared. What's the base of that power of 2? What's the base of that power of 2, Max? 4n. So what's being squared is 4n, right? We're multiplying 4n times itself. What makes the 4 part of the base, what we talked about, are those parentheses. Okay? Now, of course, you're aware of the rule for multiplying. You can multiply things in any order, right? So even though our 4s aren't right next to each other, we can combine those. 4 times 4 gives us 16. And we have an n times n, which is an n squared. Right? It would also be okay to leave this as 4 squared n squared, not multiplying out the 4. And that's actually going to serve us better to see how this rule works. So on a test, either one would be fine. Okay? Either 4 squared n squared or 16 n squared. All right, the next one. What's the base of that power of 3? What's being cubed? What's the base of the power of 3? Anthony.
5 times x times
Vince.
y cubed.
5xy squared, right? So if we're writing this out in expanded form, it means we have 3 5xy squareds. Since all of that is in the parentheses with that 3 on the outside, it means that everything in there is part of the base. So it's that times itself times itself. Okay? Looking at what we can combine here, like I said, even though our 5s aren't right next to each other, we can still multiply them all together. Essentially, we've got 5 cubed, yes? How many x's do we have all being multiplied together? 3, so that's x cubed. How many y's do we have all being multiplied together? 6, good job. Y squared, y squared, y squared, total of 6. So 5 cubed, x cubed, y to the 6th would be an acceptable answer, as would 125 x cubed, y to the 6th, which is what you would get if you took 5 cubed and multiplied it out. Okay, so either answer would be acceptable. All right? The last one, oh my goodness. What is the base of that power of 2 outside of our parentheses here? What's being squared? Ellen? Yeah, everything inside of those parentheses, right? So in expanded form, it's going to be 5n squared over 4t cubed times another 5n squared over 4t cubed. Okay? Whatever is inside of those parentheses times itself. And it's a good thing we know how to multiply fractions. What does our numerator become? Catherine?
5 to the 2nd and x to the 4th.
Good. 5 squared, 5 times 5, and n squared times n squared is n to the 4th. What does our denominator become? Kylie?
4 squared and
Good. 4 squared t to the 6th, right? 4 times 4, 4 squared, t cubed times t cubed, t to the 6th. Okay, and it would be fine also to put that 5 squared as a 25 and the 4 squared as a 16, right? All right. I think we've done enough here to develop a rule. Okay? We've got 2 different bases here. We've got a coefficient base and a variable base, right? Because for example, in our first one, that 4n squared, that 4 is a coefficient that's part of the base, right? So that would be our coefficient base. In number 2, that 5 is a coefficient, but it's part of the base. That's our coefficient base versus our variable base, which would be obviously the variables, right? So what's happening here? Anyone who's seen things going on? Yeah, Andrew.
Take the power and basically just multiply it into each number.
Yeah. Okay. So our exponents for this rule are multiplied. Okay. We can see that best in the second one here when we take that 3 times 2 to get y to the 6th. And we see it in the third one when we've got 2 times 2 to get n to the 4th. And 3 times 2 on our t to get t to the 6th. So we've got one rule where exponents are added. That was CO10, right? We have one rule where exponents are subtracted, CO11. Now we've got a rule where exponents are multiplied, right? CO14. So it's going to be very important for you to put a help sheet together. Even if you think you don't need it, it's better to have it and not need it than need it and not have it, right? So we've got all kind of come together here, make a help sheet. What about our coefficient bases? What happens with this 4 here, with this 5 here, the 5 and the 4 there? What happens there? Ellen?
They were like put with the exponent like you did with the exponent.
Yeah, they just kind of take on the power, right? They get the exponent, and you can either keep them the same or multiply it out. Okay, so they can be multiplied out. Like I said, you could write that 4 squared as 16 or leave it as 4 squared. You can write the 5 cubed as 125 or leave it as 5 cubed. But it gets the power, and can either be left alone or multiplied out. Yeah.
For the last one, could you do like 25 to the fourth over 4 squared and t to the 6?
You only want to multiply one of them out? Yeah. Yes, you can. Yeah. Our variable bases, our n that we had here, our x, our y, our n, our t. What happened to the variable bases? They stay the same. Okay? Stay the same. If there's not already a power assigned to the variable, I mean, technically it's n to the first, so our rule of multiplying 2 times 1 still holds here, but it stays the same. Okay? And then any base without an exponent already will take on that power similar to a coefficient would. So there you go. Your 5 rules for simplifying exponent expressions. Isn't this exciting?
Yeah.
Think of how powerful you are now. Powerful you are. That's good. All right. Looking at some examples here. Again, you're going to be annoyed with me because I'm going to make you write this out in expanded form on the first page for the first 6, but then not on the second page. 3n cubed. What's being cubed here is that 3n. So we have 3n times 3n times 3n. Give me one of our possible 2 answers we could have for this. Jack. 3 cubed n cubed, right? If we use that rule, distribute that 3 into our coefficient base, we get that 3 cubed. Distribute the 3 into our variable base, we get the n cubed there. How else could we write this?
27n cubed.
Good. 27n cubed, right? 27n cubed. Pick another one to go over. What looks intriguing? Catherine, is that a hand up? The last one. All right. 3n to the negative third over 2n squared, all being squared. Okay. Any thoughts on what we should do first here? What might improve our situation a little bit? Ellen?
So I would move like the negative n to the negative third down, and then I would do that, and then I would write it out.
You're a pretty positive person, aren't you? You don't want to deal with that negativity, right? Yeah. If given the opportunity, I tend to simplify within my parentheses first. It tends to either give you smaller numbers or just, I mean, anytime you got a negative anything, it just lends to a mistake. So if we simplify our parentheses first, which again isn't necessary to do, you could distribute right off the bat, but it does make it a little bit easier to work with. And that n to the negative third, once it's moved down, becomes n to the positive third, and then we can combine it with our n squared to give us n to the positive fifth. Right? What's that? Yes, because when I move this down, my denominator becomes 2 times n squared times n to the positive third now, because when you move that power down, it becomes positive. And then I can combine these to get a total of n to the fifth there. Okay? And so now, what are we distributing? We're distributing in this 2, but it's going to our 3, it's going to our coefficient 2, and it's going to our n to the fifth. It's only going to 3 things versus 4 if we didn't bring that negative power down first. Okay? If you distributed first, then you have to bring it down anyway. So like I said, I mean, you got to do it at some point, but it's up to you when. And we get 3 squared over 2 squared n to the 10th, or 9 over 4n to the 10th. Okay? Another one. What else looks fun? Yeah, Jack.
Doesn't look fun, but
Oh.
The third top and first bottom.
The last one in the first row?
Last one, first row.
Okay.
Second.
Oh.
First one on the bottom row.
Oh. Is it a coincidence that both of them have a negative sign? Probably not. Okay. Negative 4n cubed squared. In expanded form, what's being squared? Negative 4n cubed, right? So when we write this out, negative 4n cubed times negative 4n cubed. Okay? The parentheses aren't necessary in this case. I'm putting them, however, because if I don't want to multiply out this -4, this is wrong. This is right. Okay? That negative sign being part of the base in the original expression, we have to keep it part of the base when we write our answer. Right? So even though these parentheses in this intermediate step aren't necessary, I'm putting them there to remind myself that I'm going to need them when I write that -4 squared. And how many n's do we have in all? 6. Okay. What's the alternate way to write this? Bryn? Good. And that's a positive 16n to the 6th, right? Because that -4 is part of the base. So when you square it, it's -4 times -4, which is a positive 16. Okay. Good. Question on that one? Okay. The last one there, 15x to the -2nd, that being squared. This time, I'm not going to move my negative power down, just because we did it last time, so this time I won't. But we've got 15x to the -2nd times 15x to the -2nd. Okay, what's being squared is everything inside of our parentheses. Give me one way to write this, to combine this here. Kylie?
15 squared x to the -4.
Good. 15 squared, x to the -4th. At this point now, I would have to move that x to the -4th to the denominator and make it positive. Okay. What's my other way I can write this? If you don't like the 15 squared, what's the other way you can write this? I'm basically asking what 15 squared is. Anybody?
Oh my gosh. I meant 125.
Oh my gosh.
Yeah.
225. Sorry.
30.
30.
Fun with the master.
Either answer is acceptable. 15 squared over x to the 4th or 225 over x to the 4th. Okay? Questions on this? Anything that you're not quite clicking with? Okay? Because using the rule is easier than writing out an expanded form, and that's obviously by design. That's why we have the rule, right? So on the back side here, when it says the goal here is to not have to write the expression in expanded form, okay, I still need to see what you're doing, but it doesn't have to be in expanded form. All I need to see here, Alex, before you start to, okay, distribute the exponent into the 7 and the n. Can you handle that? Is that too much? You can make those arcs shorter if you need to. I mean, whatever. Okay. But what you end up with then is that 7 squared n squared or 49 n squared. Either one's fine. Okay. On the next one, I need to see you distributing the 3 to the 10 to the a to the 5th and to the c squared. What do I get? Give me one possible answer for how you could write this out. Kylie. Okay, give me another possible way you could write this out. Will? That was on purpose. Ellen?
1,000.
Yes. 1,000, a to the 15th, c to the 6th. Either one on a test will be acceptable. There you go. Okay. Any on the backside that you want to talk about? Let's do this one here. So basically, like I said, everything inside of the parentheses gets that exponent on the outside. So this 3 would go to the 2. It would go to the n. It would go to the 3. It would go to the x. right? Every coefficient, every base, okay? And so that would give us in our numerator 2 cubed n to the 15th, right? That 2 gets the power. The n to the 5th, those powers are multiplied. And then in our denominator, it would be 3 cubed and x to the 6th. Okay? So you are distributing that exponent into every coefficient and every variable inside of the parentheses. If a variable already has a power, you multiply them. If not, it just gets the exponent there. Will? Fourth row, second one. Is that what you're asked about too? It must be a doozy. I don't even know what it is here, but let's see. Fourth row. 1, 2, 3. Oh, you got this. You got this. Hey, you got this. All right. What should we do first here? Take a look at the elements here. What should we do first here, Catherine? Yeah, the a to the 0 doesn't come into play here. If you were to distribute that -2 in there, 0 times -2 is 0 anyway. So anytime you've got a 0 power, just eliminate it. Just get rid of it. Okay. Should we bother moving that b to the -7th down to the denominator?
No.
Why in this case wouldn't it make a lot of sense to do that, Alex? Right, because since this exponent that we're distributing in is a negative, it's going to change the sign of everything in the parentheses anyway. So if we move it down to make that b to the +7th, when we distribute it, it's going to become b to the -14th, and we're going to move it back up again, right? So when you've got a negative exponent, I wouldn't touch anything on the inside as far as moving it, because all the signs are going to end up changing anyway, right? That 5 will become 5 to the -2nd power. That b to the -7th, because like Alex said, a negative times a negative is a positive, is going to be b to the +14th, and it's actually going to stay right where it's at. The c, 10 times a -2, is a -20, and that's going to end up being moved as well. So our final answer, our b to the 14th is going to stay up top, because now that exponent is positive because of the rule. 5 to the -2nd becomes 5 to the +2nd, or 25. And c to the -20th becomes c to the +20th. Okay? All right. Other questions? The rest I'm going to let you do on your own for tomorrow, but if there's anything you're still that's not quite clicking, now's a great time to ask. Other questions, comments, concerns, complaints, comments, congratulations, or criticisms?
Thank you.
You're welcome.
Thank you.
You're welcome.
Thanks. No, thank
You're welcome.
Thank you for being math.
Why you gotta be so mean? All right, folks, that's our math.